Good day, everyone. I am the Cadet Kyle Anthony B. De La Cruz, and together with my team, the Cadet Belangigi Ramilo, the Cadet Buok III Filomeno, and the Cadet Conyado Steven, we are going to present our oral presentation for our finals in MTech 101, and we are the Group 3. And for our course outcome, to solve the given problems by the Great Sailing Circle in determining the DLAT, the D-long, Great Circle Distance, initial course angle, initial course through, final course angle, and lastly, the final course through. And for our learning outcome, at the end of the session, the students shall be able to determine and solve the given courses and distances by the Great Circle Sailing. The importance of the topic. So, the importance of the topic is the shortest distances between any two locations are along the Great Circle routes. These circles are useful for determining the shortest routes between any two locations and assist navigators save time. And for our problem, determine the Great Circle distance, initial course and final course from latitude 1, 24 degrees and 52 minutes north. Latitude 2 is 47 degrees and 19 minutes north. For the longitude 1, 78 degrees and 27 minutes west. To longitude 2, 6 degrees and 42 minutes west.
Hi everyone, this is Cadet Belangigi, and I am going to show you how to calculate for the DLAT and the D-long. So for example, we have here the DLAT and the D-long, which is first we have the latitude 1, which is 24 degrees and 52 minutes north. The latitude 2 we have 47 degrees and 19 minutes north. So in calculating the DLAT, so note that same names subtract. So the latitude 1 and the latitude 2, you have the result that 71 degrees 44.6 minutes south. Okay, so and the longitude, we have the longitude 1 and the longitude 2, which is the longitude 1 is 78 degrees 27 minutes west. The longitude 2 is 6 degrees and 42 minutes west. So we have the result of the D-long, which is 71 degrees and 45 minutes east. So as I say, if same names, subtract. If different names, add. Okay, so if the D-long is greater than 180 degrees, subtract, we have to subtract to 360 and reverse the name. Thank you.
I will be reporting about the Great Circle distance. So, in order to solve the Great Circle distance, we have our formula, which is cos GCD, cos lat 1 times cos lat 2 times cos D long, plus or minus sign sin lat 1 times sin lat 2. So firstly, we need to substitute our cos lat 1, which is cos 24 degrees and 52 minutes. Our cos lat 2 is cos 47 degrees and 19 minutes. And cos D long is 71 degrees and 45 minutes. And also, our sin lat 1, which is sin 24 degrees and 52 minutes, times the sin lat 2, which is sin 47 degrees and 19 minutes. So, first, you need to multiply the cos lat 1, cos lat 2, and cos D long, which is the product of 0.90729 times 0.67795 times 0.31316. And we will use the plus sign because it is a same sign. And for our sinlet 1 and sinlet 2, the product is 0.42051 times 0.73511. So the next is you need to multiply them both. So we will have the product of 0.19262 plus 0.30912, which is the sin, the product of the cos lot and the sin lot. So we have the product of 0.50174s. So in order to have our GCD, the 0.50174 seconds, you need to use a calculator and press shift cost and then type the 0.5014, and it will be a answer of 59.8848156. Then shift degree, you will have the answer of 59 degrees and 53 minutes 0.5 seconds. In order to convert the to nautical mile, you need to multiply it by 60. So 59 degrees and 53 minutes 0.5 seconds times 60, and our GCD would be 3,593.5 nautical mile. That will be all. And also, I almost forgot about the great circle distance. The note is, if same latitude names, add or plus sign. If different latitude names, which is subtract or minus. To convert GCD to nautical mile, multiply it to 60. So don't forget, guys.
So, good evening, I'm Cadet Sanji Gunyado, and I will be discussing the initial course angle. So, first we need to find the initial course angle, and we have here the example. So, the example of initial course is the formula on it is cos latitude 2 times sin's different longitude slash the sin's great circle distance. So, the cos is 0. So the latitude of the latitude 2 is 0.47 degrees and 19 minutes, and then the different longitude is the 71 degrees and 45 minutes, and the great circle distance is the 59 degrees and 53.5 minutes. So to get the cosine of the latitude 2, is we need to get the root of the 47 degrees and 19 minutes. So we have here the answer. So the answer is 0.67795. So by the way, to get the answer, we must use the scientific calculator also, so that we can know the root of the latitude 2. So let's proceed the different longitude. So the different longitude, it's the same to the cosine. We need to press the sign and sin, and then type the different longitude. So the different longitude is 71 degrees and 45 minutes, and then the result is 0.94970. And then lastly, the great circle distance. The great circle distance also the same to the first one. So we need to press the send and then type the total of the great circle distance, and then the result of the great circle distance will be the 0.86508, and then after that we need to use the the coastline and the different longitude, and then times it, and the result will be 0.64385, and then copy the great circle distance, and after that we need to divide the 0.64385 to 0.86508, and then the result will be 0.74427. So next one is the initial course angle. So we need to use the shift since, and then the total of the initial course, and then the result will be 48.096472 shift degree. And then next one is we need to copy the sign. The sign of the first one in longitude 2 is the north. So need to put the north in the first is north, and then put the 48 degrees, and then 5.5, and after that will be the S there, and then convert to the true course. And then the initial course of the true course is 48 degrees and 5.5 minutes through. So next one is the initial course. Initial course angle will be the great circle distance must be in degrees, and make latitude 2 negative if crossing the equator naming. So prefix according to the latitude 1, and suffix according to the d long. So to get the true course, will be discussed of cadet book the third. So that's all.
Good day everyone, I am Deck Cadet Book Filomeno III, and I am going to talk about how to find the final course angle. So the formula of the final course angle is cosine lat 1 times sine d low over sine GCD. So the lat 1 is 0.24 degrees 52 minutes, and the d low is 0.71 degrees 45 minutes, and the GCD is 0.59 degrees 53.5 minutes. So cosine lat 1 is equals to 0.90729. The sine d low is equals to 0.94970, and the sine GCD is equal to 0.86508. So multiply the cosine lat 1 times sine d low. So the answer is 0.86165 over 0.86508. So the sine final course angle is equals to 0.99604. So final course angle equals shift sine, which is the 0.99604 is equals to 84.89931,335, then shift the degree to the final course angle equals to the south 84 degrees 53.6 minutes east, and minus 180 degrees to find the final true course. So south 84 degrees 53.6 minutes east minus 180 degrees is equals to 304 degrees 14.0 minutes true. So the 304 minutes 14.0 true is the final course angle. That's all. Note the final course. GCD must be in degrees. Make latitude 1 negative is crossing the equator. Naming. Prefix contrary to latitude 2, then the suffix same as the dilo. That's all. Thank you.